This video in the series of permutations. In this video we'll look at permutations but with certain restrictions. Let's do a quick recap of what we've already learned. How many different different six-letter arrangements can be made from the word spider? Because we're choosing from 6 letters, the first letter can be one of the 6, the second letter could be one of the 5 that are left over, and then one of the 4, 3, 2, and 1. This is 6 factorial, or 720 different arrangements. Let's look at something slightly different. How many different 4-letter arrangements can be made from the word spider? So we're choosing from 6 letters, 4 at a time. This is 6 times 5 times 4 times 3, or 6p4, which we get an answer of 360 different arrangements. Now, how many different 6-letter arrangements can be made from the word spider if we use the restriction of the 2 vowels have to be together? Well, we're going to treat the 2 vowels as one group. So pretend that we've got to keep this I and this E together no matter what kind of arrangement we have of the word spider. We now have 5 positions, not 6. So our multiplication will look like 5 times 4 times 3 times 2 times 1, which is 5 factorial. However, for every one of those arrangements in that 5 factorial, the vowels could be switched between IE and EI. This can be done in 2 factorial ways. So we need to multiply our answer by 2 factorial, which gives us 240 different arrangements. Let's look at example 7. In how many ways can 6 students and 2 teachers be arranged in a row if the 2 teachers are together, or the 2 teachers are not together, or there are at least 3 students separating the teachers? Now with 6 students and 2 teachers, you might be thinking that it's going to be 8 factorial arrangements. However, we need to treat the 2 teachers as one unit because they will be going together no matter where in the arrangement they are. So in fact there are actually 7 units. There are 6 students and the unit of 2 teachers. So this can be done in 7 factorial ways. However, each of the 2 teachers can be arranged in 2 factorial ways. So we need to make sure that we multiply by 2 factorial, giving us an answer of 10,080 different ways. For B, the 2 teachers have to be not together. Think about this. The teachers are either going to be together or they're not going to be together. So the total number of arrangements with no restrictions is going to be 8 factorial. The number of arrangements of the teachers who are together is going to be 7 factorial minus 2 factorial. We worked that out for A. So if we subtract those 2 numbers, we will get the number of ways that the 2 teachers are not together, which is 30,240. Part C is a little bit different. There have to be at least 3 students separating the teachers. So here is one possible combination where the teacher goes first and the second teacher goes fourth. Now when teacher 1 goes first, there are 4 different arrangements of teacher 2. If teacher 1 goes second, there are 3 different arrangements. If the teacher number 1 goes third, then there are only 2 arrangements. And when teacher 1 goes fourth, there is only 1 arrangement, for a total of 10 different arrangements. Now for each one of those arrangements, the students can be arranged in 6 factorial ways. Also, you need to remember that you can change teacher 1 and teacher 2 around. That will still leave you with 3 students in between. So, what have we got? We've got 10 different arrangements, which we need to multiply by 6 factorial because that's the number of ways the students can be arranged. But we've got to remember to multiply by 2 factorial because that's the number of arrangements that the teachers can be done in. Multiplying all together, we get 14,400 different arrangements. Example 8 asks us, how many different arrangements of the letters of the word Tuesday are possible if the 3 vowels are together, or the first and last places are consonants, which means not vowels, and C, the consonants and the vowels occupy alternate positions. Let's look at A first. The 3 vowels we're going to treat as one unit. That means that there are 5 units in total, the 4 consonants and the vowels. This means that there are 5 factorial different ways of having the 3 vowels together. However, remember, there are 3 factorial ways of arranging the vowels, so we need to multiply by 3 factorial. This gives us an answer of 720 different possible arrangements. For part B, the first and last places are consonants. So let's draw up 7 positions. The first position has 4 different consonants that can go first, meaning that the last position has 3 different consonants that can go last once we've used the first one. For the rest of the numbers, there are 5 numbers left over, which means 5 factorial different ways of arranging them. Using the multiplication principle, we see that we're going to be multiplying 4 for the first letter, times 3 for the last letter, times 5 factorial for all the letters in between, giving us an answer of 1440 different possible arrangements. For part C, the consonants and vowels occupy alternate positions. There are 7 positions in total. We have 4 consonants and 3 vowels. This means that the consonants have to go first. There are 4 different possible combinations for the first consonant, followed by 3 for the second, 2 for the third, and 1 for the last consonant. As for the vowels, there are only 3 vowels, which means that there are 3 times 2 times 1, or 3 factorial, different ways of arranging them. Multiplying this out, we get 4 factorial by 3 factorial, which gives us an answer of 144 different positions that the consonants and vowels can alternate in alternate positions. That's it for now for permutations with restrictions. Try the questions from your textbook and ask for help if you need it. Good luck.